Okay, let's look at comparing decimals. I left our chart up here to show the place values as well as the names of those place values with the example underneath. I don't know that we'll need it, but it's there. So comparing by place value, just as we compare with whole numbers, 675 and 542. Okay, we compare the largest place value and we see which one is bigger. This one's pretty easy. The 6 is bigger than the 5. 675 is bigger than 542. 9,361 compared to 9,359 takes a few more steps. We have to compare. 9 and 9 are the same. 3 and 3 are the same. 6 and 5, okay, here they're different. This number is larger. We're going to do the same thing when comparing decimals. But there are a few things that we need to watch out for. So if we're comparing 3 decimal numbers, I would ask students to line them up by place value, making sure that each place value is in line with each other. The ones place must be in line, or the tens place, or the hundreds place if we're starting there. The decimal places must be in line so that the tenths places line up, and the hundredths places line up, and the thousands places line up. Now, one thing that students often like to do is say that the number that has the fewest number of digits after the decimal point, to the right of the decimal point, is the smallest number. And the one that has the most digits is the biggest number. Sometimes that's true, but sometimes it's not. And so to prevent that type of thinking, I would ask them to add zeros so that all of the numbers have the same number of digits. And they don't get thrown off by that idea of, oh, the one that's the longest must be the biggest number. Okay, so if we do that, and then we compare by place value, we can look at this and say, okay, the 1 is the same. Those are all the same. 506. Okay, 0 is smallest. So this is my smallest number. So 1.050 is smallest. Okay, and then we'll go to the next one. So that one's out. I'm just going to cross it out. 5 and 0. I'm sorry. Other two numbers, 5 and 6. 6 is bigger than 5. That means this is the biggest number, and this one is next. So we have 1.550 and then 1.605. Now, that's, to me, the easiest way to think about it because we're going place value by place value. You could also look at the last digits here and go 50, 550, 605. If you were to read those numbers out loud, 1 and 550, 1 and 50, 1 and 605 thousandths, then 50, 550, 605 should also sound logically to students like those are in order. Okay. Now, I also like having everything on the number line. I love number lines and I love having students visualize those because for some reason this doesn't make a lot of sense, then it can be easier to put it on the number line. We can't always put every single number on the number line because it's hard to make the number lines go to the thousands or the 10,000s. But we can break it down somewhat. So this one, we can see we've got between 1 and 2 broken up into the tenths. And then in this little section here, we've got it broken down even further into the hundredths. And I'm going to take that back away so it's not distracting. And then here we continued with the tenths up until 2.5 just because these three problems are all within that realm. So if we looked at these numbers on the number line, 1.55. Okay, so 1.55, I apologize for that sound. 1.55. Here's 1.5 and here's 1.6. 1.55 is right between them. So that's 1.55 is right here. 1.05, well, that's not even up to 1.1. That's all the way down here. It's like right here, 1.05. And then 1.605, well, here's 1.6. It's going to be a little bit further. So this gives them a little bit more of a visual, and it's not quite as abstract. It gives them some type of representation that they can connect to. And here they can see 1.05 is all the way down here. 1.55 is here. 1.605 is here. Same idea with these three. In number 2, 2.1 is here. 1.957, that's really long. I can't really find exactly 1.957 on the number line, but I could estimate, like, this is 1.9, 5 is like halfway, so it's probably right around here. I could at least get a ballpark, 1.957. And then 2.07, well, that's not to 2.1 yet, so that one's right here, okay? This is one of the ones where students might say, okay, 1.957, that is lots of digits. That's the biggest number. But again, we can put it on the number line, or we can line these up. Lining up the ones place, we have 2, 1, and 2. That means this one's the smallest because it's only 1 something. It's not even up to 2 yet. I can add my zeros here as well, and then make them all the same number. And students can't say that one number has more digits than the other, right? So that would be the smallest, as we determined. And then, so I'm going to put this as 1. 1. The second one, we've got a 1 in the 10th place and a 0 in the 10th place. The 0 is smaller. I should have said we're putting these from least to greatest. And then 2.1. Okay. All right, 2.45. Ooh, a lot of these this has a lot of digits that are similar. 2.45, 2.405, and 2.54. I'm going to add a 0 to both of these, so we have the same number of digits in each case. These are all 2, so when I compare the ones place, none of them stand out. They're all 2. And then here we have 450, 405, 540. So 405 is the smallest. 2.405 would be about here, very close to 2.4. 2.450 would be about halfway. And 2.540 would be about here. So our smallest is 2.405. Hey, it was the one that started out with the most digits. And then 2.45, and then 2.54. Right, and that is our comparison of decimals. Let me know if you have any questions.